there is also the wrench. What you do with the wrench to open the metallic cartridge. So I will put it here. So here, I recommend you to take a piece of paper, a thick piece of paper, do like this, okay? And there is a little hole here, see? You take it, and you do like this. And you open. And here we have the nozzle. This nozzle is 0.15. So this nozzle is for electrowriting. Electrowriting. So we don't need to use this nozzle. So what we have here is the PCL that I used it for. Okay, break it. I don't need this. Okay. Okay. And here we have different nozzles for the PDD. PMD, I'm sorry. This is for ESK. And we have it here for compact dispense. Okay. So, how you mount your PMD? The needle, the cartridge, you put the needle here, and you come with this part, and you screw. Okay, it's very important to screw very tight. To screw, you have to do this. Why I'm doing this with the paper? Because this cuts you. No, it's very thick paper, but usually when you do this, you cut your hands.
Sometimes also hot.
It's also hot, but you will not do this when it's hot. You will do this before everything.
Yeah.
Okay, so I will put the screw here. Here, and then we'll take your cartridge adapter. So I'm taking just your pressure adapter, okay?
Should we fill it with PCL?
It has a lot of it's a lot of PCL already. So here, close, and now we just need to screw. Okay. Screw, and now we are ready to go. There is just a little bit of PCL here, but it's okay. So see this? We have to put it here, and we have to here clip, and then we put our okay. Now we have to close here. Okay. It's closed. Okay. What should I do now?
Just calibrate.
Calibrate the needle. Yes.
Adjust.
And where I calibrate the needle?
PMD.
Yes. Calibrate the needle. Okay. After I calibrate the needle, I need to heat my material. Okay. What's the melting point of the PCL? PCL
90.
melting
90.
90 degrees. Some PCLs we use 85, but for this one, the best temperature is 90 degrees. Okay. So I'll wait a little bit.
Usually we change to 90 and wait a little bit. Wait like half hour after tuning it, getting the temperature.
Yeah, it's another thing. This one it's very fast.
Fast?
You 9 degrees and you wait like 3 minutes or 5 minutes.
Really?
Mm-hmm.
Well, you used just, okay, let it heat and then go.
Okay. Okay. And to heat, it's very easy. You don't need a liquid temperature controller to heat the PCL. Okay? Because it's built in the heater. So you put here 90 degrees and you enable. Look how fast it is. See? And while it's heating, we can design the project. Another thing, this one, it's the camera. It's the camera, but we're gonna see just after the project. So, we start again the project, shaper, and let's try to make this random. Make electrolyte is not easy, okay? Because you have to find the right electrical, how can I say, the voltage, the right pressure, and the right material melting. So I think we will not be able to do this today, okay? But we can try. So, planner plus, we come here, rectangle, and we design the rectangle that we want to make, like this one, and then you select the tool, infill, always infill, you go tool, and you select PMD, PMD, and here you can see contact dispensing, but we don't want contact dispensing this time. What we want is microfibers. So you eliminate the contact dispensing and you click plus and you put microfiber dispensing. Okay, and here the voltage. What voltage you use for the PCL? I think it's 4.5 or 6, right? 7 kilovolts? And the pressure? The pressure?
Pressure 0.07.
Which is that?
This is mega or mini? Yeah. For the pressure of the PCL, is it mega or mini?
Megapascal.
Mega, so 70 kilopascal. 70. Okay, so 70 and the material. We create the material. PCL. Let's put. What is your favorite color? So let's put green. Okay. Testing tools. So I put like 7 kilovolts and 70 kPAs. Okay. What's the 90 degrees? 4 millimeters? The distance from the collector. So the distance from the collector is the needle offset. So 4 millimeters. Okay.
Strand spacing 500 micron.
Strand spacing? Here, it's here. Yeah. So here we're gonna 0.015.
Feed rate is 40 millimeter per second. Feed rate is the
Feed
same.
rate?
Yeah, the robot speed is the same as
14.
feed rate.
Oh, okay.
Yeah.
So
Does
this
that depends on your needle?
depends on the
You
needle.
already know that, right?
Yes. So usually this is the value that I use for this material. But of course we can have some different. So we're gonna have something like this. See? It's very tiny.
Tiny.
Mhm.
You need a camera.
Yes, that's why the camera is there. So after that, after you do this, you have to go to composer, substrate. We have to put the substrate again. Glass slide. So 75, 50, 0.98. I click.
Can I ask something? Can we
We can, but like 6. The problem is that it's plastic, right?
Yeah,
It's
concrete.
plastic. The problem, yeah, it's plastic. See what's written here? Please only place ceramic or glass objects in the conductor.
Okay.
Because if you put plastic, you might not have the collection of the electric field in the plastic, because I think plastic is isolante.
Yeah,
Como é que a gente fala isso?
acho que é assim.
Yeah, I understand.
Isolante.
Is that only for this one, the third printhead?
Yes.
Yeah, it's for the collector.
Yeah, because before we print cell, we directly put into the cell, like,
But with the electrowriting,
oh,
electrospinning,
that one we cannot.
it's written that we cannot. So
Okay, okay.
it's possible to do, but we need to see the typology of
okay.
the plastic, because the
But
plastic.
if we found the web plates, glass web plates,
That would be good.
specifically
Yeah.
for this application, I know there are some.
That will be good.
We can have a combination of the printings.
Mhm.
First printing with PCL,
Yes.
then the first printhead or second printhead starts the printing cells on top of that.
Yes. It's gonna be something like this. So I saved the file now, right? Here. Job definition.